All right, well, this is the Mihai track, and so I'm happy to be on the stage. Sarah Evans, I work at Dell. 2025 is the year of the agents, so as Mihai and I were talking about security and what we could talk about at community today, I said we should give a talk on agents, and so here we are today.
Yeah, thank you, Sarah, for suggesting the talk and joining me on the talk. So let's talk a little bit of how agent got created. So 2 years ago when ChatGPT dropped, the interaction with LLM was you give it a prompt, it gave you an answer. You give it a prompt, it gave you an answer. And you relied on the context to keep expanding the problem. But that was not useful. That was soon found its limit. So people then developed LLMs with tools. You talk with an LLM, and then this LLM could reach other LLM, and it could integrate with a calendar API or with a mail API and so on. But the LLM developer would need to write the integration themselves. This was still hard to do and very slow to keep expanding. So people created a concept called MCP, Model Context Protocol, such that rather than you creating both the LLM and the integration with the tool, each API can create an MCP server for the same API. So now you have an MCP version of the calendar API, an MCP version of the mail API, and so on. And then your LLM only needs to know how to talk to the MCP, and you need to install the MCP locally if you are not using the MCP via the web interface. This works, but it's still a little bit limited because you still have one central LLM that then distributes the calls to different agents, to different tools. So now comes the agent era, where you have one LLM that then suddenly contacts other LLMs that exist in the internet, and the LLMs could talk between themselves, either using agent-to-agent protocol or other custom protocols. And you can develop the entire infrastructure using agent development kit or similar approaches. And basically what an agent is an LLM that acts upon an environment and receives back some feedback and keeps continuing. And if you want it in the Python code, it's like on the right side where you extract the environment. From there, you know what tools are available. And then in a loop, you take the system prompt plus the current state, and you ask the LLM what actions to be run, and then you execute the action, and then that gives you the next state. And you keep iterating this loop until the problem gets solved. So this is how agents work, but what is about security? We have all of these cool, awesome, super cool AI projects, but we have that insecure AI models and insecure AI agents that we kind of need to solve.
Yes, so I looked high and low across the world of security to find out, is there some secret net new security requirement that we will need in order to be able to secure AI agents and agentic architectures? And so far I haven't found one. I think that the traditional security approaches apply to this very new and accelerated use of technology. And so I always have to say, what is a good example of a traditional security approach that we need to think about is the zero trust principles. I've listed some kind of highlight quotes here, but at the end of the day, the main thing you need to make sure is that when you are architecting and using your AI agents and your agentic architectures, that you have a resource that is connecting to data, and that needs to be authenticated, authorized, and logged in the format that fits your use case. Now, even though there's no new security challenge, or excuse me, no new security requirement that didn't exist before agents, and even though we have these zero trust principles, there are still like kind of three main challenges that I found. The first one is these are very complex. You're trying to automate and abstract and have machines start reasoning through and making recommendations for what to do on your behalf. That's very complex, and each one of these use cases is different. You saw as Mihai went through each one of those use cases, the complexity is evolving. Some situations, the developers will need to understand exactly what is going on so that then they can apply the appropriate threat model and risk and security controls. These are also not super mature technologies. So there are things we know how to do in security that don't exist in the functionality of these new tools yet. That will need to grow and evolve. We'll all need to innovate there to help extend security to these tools so that we can have the security we need. And then there's legacy challenges. So I heard someone say, data security is sexy again. And I'm like, yes, it is. It's an unsolved problem. How do you classify things? How do you, successfully understand how to secure your data, and if any of those unsolved challenges are going to become worse faster as you begin to put them into an AI agentic architecture. So we still have a lot of work to do in this quickly evolving and moving space. Now, I was at RSA this past spring, and the OWASP Foundation has put out a really nice resource on securing agentic AI. I highly recommend it. They're focused on securing the application. How do you identify the risk? How do you make sure things have an identity? How do you make sure you put your security controls in place? And that's excellent. We need that. But then we also need to be thinking about the supply chain security. Yesterday morning, I was reading the news, and I found out that there is a bug that Anthropic has in an older version of MCP, and they're like, hey, we're no longer, that's the old version. We're not going to fix this bug in the old version. But it's been downloaded 5,000 times, and people are still using it. Classic supply chain security challenge to this new use case. So everything that we've been doing and training our software developers on is very, very critical to keep doing in agentic AI. So I wanted to propose that we continue thinking about how do we extend SALSA to these areas. It's very much focused on supply chain. And there's also the Secure Supply Chain Consumption Framework, or S2C2F, that really kind of helps you think through your supply chain dependencies. That actually is evolving from what I understand. Potentially there's an ongoing conversation about it becoming part of the SALSA dependency track. And in probably an hour after lunch, we're going to have the two maintainers who can talk to us about what that evolution looks like. So just very timely. This is a great community day where we're talking about evolving our software security tools to be better. And then we're also talking about how we can incorporate these new uses of AI and AI agents into what we know about software development. All right, do you want to close us out?
And to close us, right now we have agent with agent cards. We should sign those. This basically ensures that if an agent says that it does something, you know for sure that that's exactly what the agent does, so you can trust it. Also sign agent messages, sign the MCP tools, either the local ones, verify the signatures before starting running them, or if you're connecting to an MCP over web, make sure that you trust the provider. You don't send your private data to somebody random on the internet. If you are using a lot of the agents from different providers, there is this suggestion to start thinking of a domain name server for agents, such that agents can start recognizing each other and knowing their capabilities. And we need to think about how to secure this system and how to make sure that an agent cannot lie about what it does to other ones. And finally, something that can be done exactly right now is make sure that you prevent agents to access unauthorized data. So, for example, you can use Zanzibar relationship-based access control and filter embeddings such that agent can only provide data based on what documents it's allowed to touch. And yeah, and okay.
Yeah. So the AI/ML working group is a great place to come together collectively to start talking about what do we need to do to document what we know about and extend supply chain security and software developer security to these new spaces. I would say hearing about the excitement of developing on open source software, how we all developed on the same software, this feels very much like that. There's a lot of excitement around using agents and the problems that they will solve. But we have almost been given a gift in that we've had the past 10 to 15 years to understand challenges in supply chain if we don't do anything. And so now we can very proactively work together to put together some extension of our existing tools into this new space, because in 10 years, 20 years, I'm going to be retired, and these little AI agents are going to potentially be working with the healthcare that we have, the planes that we fly in that get my grandkids to me. So we have this really nice time right now to start thinking about how do we need to secure our AI agent supply chain. So I encourage you all to get involved.
Everyone.
You have a few minutes to take questions.
Mihai, I have the same question. When you say agent signing, what exactly are we signing? Is it the LLM, the environment? What is signing in
So
that context?
an agent right now is basically an LLM with some configuration files and the agent card. You should sign the LLM to make sure that that's exactly what you are going to use. You should sign the configuration, basically the context in which the agent works for. So like Claude MD or Gemini MD if you are using Gemini CLI. You should also sign the agent card such that any users of your agent is sure can have trust in what the agent capabilities are. And they are three separate pieces. It's not just one single signature. Each one is individual.
So I understand the LLM signing and I understand the configuration signing. But there's a part of it, if you can go back to the diagram, the LLM is going to the environment. Yeah, yes. So it's acting. And as long as it is acting based on whatever it's supposed to do. It acts on the environment. The problem is it gets feedback. And then as soon as it gets feedback, the weights will change. So based on your previous answer on the model signing, the model has changed now because the weights have changed because of the feedback. Or am I getting it wrong?
So it's very hard to update the weights of the model based on the output from the environment.
Okay.
What usually happens is you configure the system prompt with the generic goals for the agent and the constraints in which it's supposed to evaluate. And each time the LLM runs, the system prompt is given at the beginning, and then some context from the previous interactions, either via RAG or the entire context of the conversation. You should sign the system prompt because that's what controls the main behavior. And then everything else comes via the conversation. That is dynamic. You cannot really establish it. You cannot sign it at this point.
So prompt will be like a configuration sign, right?
Yes.
So you sign the LLM, you sign the prompt, but ultimately based on the feedback, it's supposed to reason and take decisions that were probably not in the guardrails of that prompt, right?
Yeah, but that's not something that can be solved with signing. That is more like fine-tuning the model, establishing guardrails into the model, making sure that you test the model under this behavior to make sure that it doesn't deviate too much. That's not on the supply chain part.
Got it.